Now we're going to talk about ionic bonding the rest of the day. And then we're going to talk about properties of the three types of bonds.
Are we drawing more stuff?
We are. Nothing very exciting, I'm afraid. Alright, so everything that we just drew, y'all stop talking.
Let's walk.
What?
At each box for the question, how do you not get partial credit? I am confused.
Each box is a question.
Yes.
In the boxes that tell the geometry, if you told me triangular planar and it's triangular pyramidal, it's just the wrong geometry. It's wrong. It's minus 5.
But you could have still gotten the polar right.
Yes.
So that is partial credit.
I have said this like 4 times.
Whenever I ask you, no partial credit.
Each box is a separate question.
Okay, that's partial credit. Now I'm like, see, looking at it, every box is a different color.
Thank you. Thank you. Some people over on this side are listening to me.
Yeah.
Thank you.
I get that, but I'm looking at it as if like, because they all went together. When I was saying partial credit,
I have said like 14 times, every box is a separate question. There are 18 questions on the quiz.
Yeah, but when you say
There are 18 questions on the quiz.
just take it, just take it. Just take it.
There are 2 freebie questions on the quiz. As long as you didn't miss all 18, you got 10 points free. Now, if you miss all 18, you got a 0. You do not get any points for your name on the paper. Okay? So if any of y'all missed all 18, y'all got a 0. I'm not giving you 10 points for writing your name on the paper as a sophomore through how many seniors in here? No. So if you missed all 18, you got a 0. But as long as you got 1 box right, you got a 15.
Yeah.
Okay? There's your partial credit. Okay? But every box is worth 5 points. But inside of the box, there is no partial credit.
okay.
Okay.
Oh, yeah.
I have said that I don't know how many times.
Because sometimes I think we gotta break right now.
Now, tell me what an ionic bond is.
Something that I don't know.
It's a middle and a non-middle.
Okay, that's how we recognize it. It's a metal and a non-metal. Now, we just spent 3 days drawing and learning how to detail and describe a covalent bond. What was a covalent bond? Okay, y'all are going to flunk the test on Friday.
Yep.
If that's all you got, you are not going to pass. Because I am not going to ask you questions that say metal, non-metal, or 2 non-metals at this point. I need you to tell me something about the electrons at this point.
This is where electrons are.
The dipole.
Alright, so we just drew. Alright, so we just drew structures where the electrons were shaped. Okay, those double bonds, single bonds, triple bonds, the electrons were shaped. So, are we going to draw structures for shape?
No.
So, what happens to the electrons in an ionic bond?
They're lost or
They don't share. Okay, I need something a little more specific than they don't share.
They're lost or gained.
They're lost or gained. All right. So, with an ionic bond, you can say transferred. So, how are we going to illustrate this? Can we use a Lewis structure? No. Okay? So we cannot use a Lewis structure. All right? Everything y'all just did on the quiz was for covalent. It shows shared electrons.
Well, what about the negatives?
What negatives?
The negative.
Oh, that showed that electrons were either lost or gained. So if it showed a -1, like was on the quiz, did we gain electrons or lose electrons? You gained. So you
Oh, I
should
did it
add an
right.
electron.
In that case, you can't use Why would we draw a Lewis structure?
Huh?
So why would we draw a Lewis structure?
You would still draw a Lewis structure because the electrons are shared between the N and the O, but you've gained an extra electron. Okay? Now, so how are we going to show that electrons are lost or gained? Well, let's say that we have NaCl. All right? We illustrate these by a reaction. Okay? It's very similar to what we've already done this semester by drawing a chemical reaction. Except that we're going to show where the electrons begin and where they go. All right? So what two elements make up NaCl? Okay? So we're going to write Na plus Cl and an arrow. And I'm going to change the size of this.
It looks like right. I don't know about all that now.
Now, on this side, we show
NaCl.
where the original electrons are found, which is basically the valence electrons. All right, so tell me how many valence electrons sodium has.
One.
So we draw one dot on Na.
Wait, so we just. No.
How many valence electrons does chlorine have?
7.
So we draw 7 on chlorine.
Okay.
Remember, what did you just tell me the point of an ionic bond was?
So you have one dot.
Do we have to pass chemistry?
No, you get flunked it and take another physical science.
Wait, whoa, give it one dot.
The only one, how many people have had physical science here?
Nobody.
Nobody?
That's why we're here. Right.
Well, sometimes I have people who've taken physical science and they just want an extra. I do get that periodically, so
I was gonna say that's nice.
happens every now and then.
Whoa.
So if any of you have had physical science, you know, somebody might have had Dr. Phillips. And if that would be the case, then it would truly be an elective. But since none of you have had physical science, then it's not truly an elective, so it's required for graduation. So if you flunk, you could either take Apex, you could take physical science or chemistry again. Those are your options.
Whoa.
So
Stop. Give one dot.
the point behind ionic bonding is you're showing what happens when they lose or gain. So who's losing and who's gaining?
And then losing and CL gaining.
That's what we're going to illustrate.
Wait,
Yes,
Alright,
Rosanna.
so for the, where it says show the original electrons that are found, those are the dots, correct?
Those are the dot diagrams we learned to draw before. That's all we're doing. So, we know Na has 1. We know chlorine has 7. Now, on the other side, we're going to show what happens to them.
Synthesis.
Okay? No.
So now we're actually learning things that could have one dot.
They could have what?
One dot. One dot on an A, and there's one dot in CL that's single. And it was a dot diagram.
Could somebody translate what you just said to me?
I just said we don't have single dots in this class.
But
and
that's
now we have
only for
single
this.
dots.
Those are the old dot diagrams.
Those are like what we use.
This isn't a covalent Lewis
It's
structure.
not a
No.
covalent bond.
Why
No.
is everything that I missed the day come back together? Like when I would miss days in the first quarter, nothing really related. Now I miss the one day with the dot diagrams and miss these days, and now they're connected, and it's just.
I don't know. I don't know. All right. So on this side, all right, you're going to show where the electrons go. All right.
NaCl.
I just picked that one because it's a nice, easy ionic bond we're all used to.
No, I'm saying, like, why doesn't it go in NaCl?
All right.
Like why does you sell
You
the
don't
plus
put
dot?
them together. You're showing where the electrons went. So what does Na do with its electrons?
Give NaCl.
All right. So you want to show that Na lost its electrons. So how do you show that Na lost its electrons? All right. So you said draw all 8 electrons on chlorine. That's good. So we're going to draw all 8 on chlorine. Yep. All right. No electrons on Na.
So draw a circle.
Draw.
All right. Nope.
-1.
So there we go.
Oh, she got it.
So what are we going to add to them?
Oh, the plus one on the.
What do we call those?
Oxidation number.
Oxidation numbers. All right. So we're going to add some oxidation numbers.
Good thing I know.
All right. So we drew dots.
Hold on.
So we drew dots on the one that gained. No electrons on the Na because it did what?
Lost it.
It lost the electrons. So I didn't draw any on Na because it lost them. We drew them on the chlorine because y'all said it gained them. All right. And y'all said draw in oxidation numbers. So what oxidation number is Na going to have? But it lose. Yes. +1, which means it lost 1 electron. And what are we going to put on chlorine? -1, which means it gained 1 electron.
Why is it the opposite? Is that like a
Because it means you have more electrons than the protons. Yes. Say what now?
Are we past 60?
We're on day 55.
No! Quit asking. I'm sorry.
She's still
She's gonna take it out.
Yeah,
Maybe
maybe
she'll forget.
I'm gonna forget.
People forget.
This is what's going to happen.
How do you even do
You will not need the oxidation sheet to write chemical equations until the gas laws. And the gas laws are our next topic, and they're a math topic. And you will have to write balanced equations to do gas law problems. And we will do those after day 60.
No, but here's the thing,
Do
y'all.
I still what?
That means 35 days.
Do I still get paid if y'all all make A's or if y'all all make F's? Or if we have a scattering along the bell curve? It doesn't matter. I still get paid. I still get paid whether I'm in the blue or I'm in the red. Would you like to take a stab at where I'm at?
You're in the blue.
I'm in the blue.
You're in the yellow because of me.
Annabelle, I will even be in the blue with you testing.
Question.
Yes.
When we get to all of that, and you know how we have like the oxidation. I know you probably taught us how to find the oxidation.
I will review it. Yes.
benzoate? How you supposed to find that?
Benzoate is not one you're going to be expected to know.
Well, like,
Alright.
we have like the transition then, like.
Yes, dear. All right.
Keep
So let's say
and we're gonna keep a count now.
Everyone is going to.
So if you just said we're on day 55, so there's 90 days this quarter. So that means 35 plus.
suppose we're doing magnesium plus fluorine. How many electrons does fluorine have?
7.
7.
Okay. Everybody with fluorine 7?
Yeah.
Okay.
Sure.
I'm a little worried about those of you who said sure.
Just me.
We're
Okay.
just gonna go with
Do you really know how they got 7?
I'm guessing it's on the oxidation sheet.
It's in group number 17. 17 has 7 electrons in the outer shell, right?
If you drop the one.
Yeah? You remember what you asked for before the quiz, Annabelle? 1, 2, 3, 4, 5, 6, 7. That's how they got 7. Okay. How many does magnesium have?
2.
Okay. All right.
Oh god.
So, what's going to happen?
Let me do all
Kick
the
an electron out.
She's gonna lose one.
No.
Lose 2.
Yeah.
Easier to lose two.
Magnesium will lose 2 electrons, right?
Yeah.
And fluorine.
Oh.
Do we get a round of applause for Steven?
Class is not
That's
over.
what you get for trying to name the oxidation sheet.
This oxidation sheet is still going.
Yo, that's why I'm gonna make Steven a little name tag, okay?
Who's Steven?
The book baby,
Oh, okay.
we can give him a little name tag. Wait till I come back. I'm at a shit collection when I got it.
I'm getting so tired of this board reading. It's the 3rd time today.
Really? I remember, yeah.
Hard drive's going on the computer.
On this computer?
I'll see you need a new computer. I think I can get you right now.
All right now. I've already done one tech help. I've talked to them 3 times personally. I guess I'll do another tech help today.
Good luck.
Thanks.
Could you use one of these?
I could. Annabelle, what are you doing?
Who taped your scissors shut?
Kate De La Cruz.
Okay.
She taped my drink bottles closed too one day.
That is so annoying. How is There's no way to get this out.
This one we got Steve and a little name tag.
I was making him one too, but the scissors are taped shut.
She taped my water and orangeade shut one day too.
Who taped them?
Kate De La Cruz.
Kate De La Cruz. No.
No, we gotta be at the, okay.
That's at the top. It's gotta be at the top. Hold on.
People gotta be able to see Steven. Can we put it over the smart sign? You don't need
I was
that.
about to. No, okay.
You don't need a school girl. Can put it right there. No, put it over the smart sign, silly. There we go.
Steven.
You do know I'm going to take that down.
No, you're not. That's why I want
Oh, that's so cute.
You can make it smaller.
We need Steven a name. He's got to be recognized by.
You want us to make it
and we're gonna
smaller? Keep this up so you can make it smaller.
Oh no, Steven is fine.
He's lovely. Don't take it down.
Saying that way.
Yes,
Even stupid people get played.
No, he's saying that to everyone else. Funny story. I fell asleep.
Don't take Steven off. Let Steven breathe.
Let him be great.
He ain't getting no problem.
This right here, though, let me tell you. This is what's gonna get me through. If you're wrong.
All right, let's try MG plus F again.
MG plus
Steve goes and I'm gonna go down. That is
35 days.
35 days. It's like basically a month. And like it's gonna fly by because we still got prom, spring break, Memorial Day weekend. You get May 1st off. That makes it 34 days.
All right. So if we move on beyond Annabelle's wacky math, so
I'm gonna go count. Just
MG's going to do what?
lose both.
It's going to lose both. So F will do what?
That's too many.
It's going to gain 1.
Because it only needs 8.
It only gets 8. So that means it has gained 1.
Oh,
really looks like we just
Look at this function.
Stop! Right
No, I'm lying.
Steven said,
Wait, what's going on?
Steven said, city girls from
Oh, you better write it on the board.
Yep.
No.
I just got a lot less space to work with. I'm done with Steven today.
Steven acted up. He didn't want it. Y'all, somebody put in the wrong software. Steven.
Hold on, for real.
All
We
right,
have
so
30 days left of school until exam week.
that's fabulous. Shut up and let's move on. I'm tired of you today. All right. So we have 8 electrons on fluorine.
Right.
Magnesium lost 2, and we have an extra down here.
Where'd she go?
So that's my question for y'all. Where's it going?
That's a great question.
It can't go to space. So what are we going to do with it? All right, we have to add something to it in order to give it a home. I heard somebody over here say the right answer. There you go, Faith. Very good. All right, we're going to add another fluorine. Now, we can only add either a magnesium or a fluorine. We can't add any other weird elements. We can either add a magnesium or a fluorine.
How do you know which one? to
Okay? Now, if you added magnesium would do what?
They want to lose it too.
It would lose 2 also, which would give you 3 electrons that need homes. And would that help us?
No.
No, that would create more issues for us. So that's not going to help us at all. So, if we have a fluorine, adding another fluorine has 7 electrons to begin with. So, if we have 7 electrons to start with, this one can just go right there. And now, both of those electrons have homes. Now, magnesium lost 2. 1 went here, 1 went here. Each of them have an oxidation number of -1. Now, we have one last thing we have to do to that. What's the last thing we need to do?
Make the normal.
Think back to what we used to do.
We have to
I heard it.
balance.
You have to balance. How many fluorines are here?
This is not fun.
How many fluorines are there? So we got to put a 2 right there. That's it.
That is aggravating.
And that's it.
No.
That's not.
I feel like it's just gonna get progressively worse. It's on me.
Okay? Question.
No, ma'am.
But
All right.
What's wrong with Steven? He needs help.
He does need help. What he needs is a new hard drive. Yep, the computer
Because
needs
it's
a new
a
hard
new
drive.
board.
New hard drive.
It's not the board, it's the computer.
Basically, Steven needs a new name. It's gonna be Steven 2.5.
Alright, we can try him, but I don't know if he's gonna work. Alright, so let's say that we have, alright, let's say that we have K plus O. Alright, how many electrons are on K?
1.
Alright,
And 6.
and 6. Alright, so what's K gonna do?
What would you do?
They need to. But they ain't. They need to. But they ain't. I don't care. I'm gonna get it.
Alondra, stop talking. Alright, so K lost 1 and O has how many? It has 6. 7? 7. So if it only has 7, is it happy?
No, because it needs one
It needs
more.
how many more? It needs 1 more. So what are we gonna do?
Add an A.
Add another K.
And you gotta balance it, put a 2 in front of K.
Okay, so we're gonna add another K. K will do what?
Give 1.
It will give 1 to the O. And now,
Happy.
what oxidation number do I put on O? A who 2?
-2.
A -2. Alright.
And 2 in front of the red K.
And put a 2 in front of the K.
Heard.
Questions? Now,
It's a hazard now.
Nakaya asked me, why did I draw my O electrons the way I did?
Because of the way it's.
Yeah, why?
Because of the configuration thing.
Because of the electron configuration.
Yeah.
This is a 2s2, 2p,
Oh my
4,
All tied together? Yeah. That's why I feel like we got the
2, 1, 2, 3, 4. So these two are paired, single, single.
Then why don't we do that?
Then why what?
We didn't do that the last time.
Didn't do what the last time?
The whole spacey space.
Yes, we did do the whole
No, we
spacey
didn't. You
space.
just put it 2, 2, 2. You said just put it on there.
No.
No, we did not do 2, 2, and 2. If you drew a dot diagram and said 2, 2, and 2, I marked that stuff wrong.
Oh, so you want to go to all this stuff?
Yes, dear. You don't have to, and I'll just mark it wrong. And then you can argue with me the way Annabelle did about partial credit. Now, mind you, they're only worth 1.2 on the test. So if they're only worth 1.2,
Okay, but see, that 1.2
are we
adds
doing-
up.
yes, but am I doing partial credit out of 1.2?
No, but like, we did that math yesterday, that's kind of scary.
I'm just
If
telling
you
you.
get 60 out of 79, that's only 19 questions missed. You get a 75.
I'm just-
70.
yes, I know. I'm just telling you. I'm not working at partial credit out of 1.2. So keep that in mind. All right.
Just make it a flat 100 too.
I'm not making a flat 100. All right, so let's talk about properties. O of metals or metallic bonds. All right, now I'm going to try very hard to remember everything I want to tell you about metallic bonds before I switch to ionic bonds.
Stop.
I'm forewarning you that sometimes I forget and I have to go back and squeeze things in.
Hey, come on, man.
I'm just telling you.
So,
You've been at that for a long time.
You might want to leave a couple lines at the bottom of metallic bonds when we finish, because sometimes I forget.
You've been at this for a long time.
And sometimes I forget.
Do better.
Well, thank you.
I try.
Because I'm writing it down.
Okay, that's why I told you ahead of time that sometimes I forget and I have to come back and add things.
Or are you talking about ionic bonds?
I'm going to do metallic first, and then I'm going to do ionic bonds. Now, I may only get through metallic today, but tomorrow I might realize, oops, I forgot something about metallic, and you might have to go back and squeeze it in. Now, yes, last, I guess it's Tuesday, so last week, what did we say about a metallic bond? What kind of bond did we say it was? What did its electrons do?
Answer the question.
Yeah.
What did we say about their electrons?
Hard metal.
Yes. All right. These electrons are donated to a region in space.
So wait, Miss Wall, do we have electrons?
All right. Yes, you have electrons. You have atoms in your body.
Did we ever move 6 in this class?
Probably not.
What?
I'm not moving.
I still don't understand how we don't.
Right, I like to see.
How you do what?
How we
So
don't.
what is that- what about
It's like, you know
losing
how atoms are mostly just space?
I lost a couple brain cells.
So why doesn't my hand go through the desk?
We got
Because solids atoms are very, very close together. We're going to talk about that after we do the gas laws.
All right.
Okay. So,
I don't even like that.
Never mind.
alright, so if we consider that the pluses are the nuclei and the E with the minuses are, alright, I'll be writing on the board.
Steven! Steven, that's not funny no more.
You're doing too much. It's not popular.
That's why you want to beat your son. Why you let him act up like that? That's why you need to tell him act up. You can get snatched up.
No,
He's
but
acting up.
That's why you
y'all
need
seen
to tell
those
him.
Landon Romano videos? You know his boyfriend's name Steven. But Steven.
That's why you need to tell him you a sitting up for 36. You snatched him up.
Okay, now. It's a mess.
They finna, she's finna.
Just imagine him once.
I'm just falling. I can't run my face.
Say that.
Period.
Yeah. He's like, okay.
This boss said period.
Huh?
That's why I said period.
Don't say it.
Now, the electrons in a metal, alright, these electrons are able to move wherever they want to go.
I'm confused. What is that?
Those are arrows.
No, I'm saying, what is that?
This is the inside of a metal. All right, these are the nuclei. It's just a cross section. Okay, and these electrons can go wherever they want to go. All right. So the thing that makes a metal unique is the electrons in a metal. And those of you at the back, I'm sorry that this is so small. The electrons in a metal can move anywhere throughout the metal. Alright, so the electrons in the metal can move through anywhere throughout the metal. Okay, that's what my red arrows are trying to denote. So we refer to these electrons as being, the electrons are mobile or freely moving. Okay? The electrons are mobile or freely moving.
Fix that word for Caleb.
I ain't gonna waste my time. Try switching it out with the one that's recording at the moment. That's wasting my time. Now, because the electrons are freely moving, what properties do metals have that ionic and covalent compounds are not going to have? I know I say this often, but can you think back to another science class or even middle school that have, when y'all talked about metals, that have specific metal properties that you might remember? What things that metals do that other compounds don't do?
They're hard.
Okay.
They're
Shiny.
Okay.
Rush.
They're what?
What?
All right. Heat's good.
What are you talking about?
Cool down.
Conduct.
Yes. There we go.
Wow, this
All right. Metals are good conductors of heat and electricity.
And bad insulators.
Okay, they are bad insulators. All right, they're shiny
What do you mean they're bad? Okay, what is it?
or lustrous.
Oh, I remember that word.
Oh, yeah, that's very close.
Okay, they're shiny or lustrous. There's a D and an M word I'm
You didn't
looking
write
for also.
insulator down.
The D is the M word.
I like how Chris had his phone out, he's like zoomed in. And
Look,
Wait, what did you say?
I have several people that do this every day in various classes.
That's pretty funny. It's like that kid that FaceTimes the boiling water to see it boil over.
And
That's what it said.
ductile.
You don't do that. You gotta go somewhere where you.
Anybody know what ductile or malleable means?
It is in the hole.
All right, malleable is a little more specific than just bendable. Okay, malleable means it can be rolled into sheets.
What?
Okay, best example I can give you of that is aluminum foil.
Hey, I don't know how to.
Okay, malleble's like aluminum foil. It can be rolled into sheets.
What did you just say?
All right.
Ductile is hard and can't be moved.
No,
Did you say
ductile can be drawn into
Oh my God,
wires.
Destiny.
What did you say?
Get off of me. Let's go back.
She said she's malleable.
When I said I'm malleable.
Yeah, Destiny's a freak and she's dead, right?
Okay, I wouldn't have necessarily said you were malleable, but okay. Now, we can use the word malleable in a different context than we do in chemistry class. All right, now, everybody have those four?
Yeah.
All right, I'm going to erase some things at the top.
Imagine like science like that. Hey,
I'm malleable.
so what would be the drawn into wire?
Like copper wire. Any of you who wear jewelry, gold, silver, platinum, those are pretty malleable. Ductile because you can make jewelry out of them. Tin is pretty ductile. But copper is the easiest one to give you an example of. Now, metallic bonding is the strongest of the bonds. So tomorrow when we talk about this in relation to ionic and covalent bonding, because it's the strongest bond, it's going to have the highest melting point and boiling point.
Wait, what's the strongest bond?
Metallic. We're only talking about metallic. I haven't switched to ionic or covalent.
What?
Okay?
Oh. So if it when it has the
I'm
strong
growing
bond,
now.
if it's boiling point's higher.
Yes. Yes.
Oh my God.
Okay, so anytime your boiling point's higher, you know it's a stronger bond. Okay?
Oh, this is a lesson.
So, to reword what Nakaya said, she said if the boiling point or the melting point is higher,
Can't relate.
that tells you it's a stronger bond.
No.
Okay over there, Nalasia?
Or your nerves
It's
is
growing.
she said she got hiccups, so she's growing.
She needs to grow a little more, so that would be a good thing.
Yeah.
Let her
Look,
hiccup all
she
she
need to
wants.
have them at least 2 times a day. No, look, how about your feet can't even touch the floor?
First of all, they're not thirsty.
I love this class.
How tall are you?
It's so hard.
4'11"?
Oh, please call me.
Miss Wall,
Yes,
do you have Joyce Quintero?
I do.
Can you send her to the office, please? She's leaving.
I will.
Leaving, you didn't tell
Thank
me.
you.
Okay.
Where?
That's messed up. I hope Katie's here.
You want to take Annabelle with you?
Oh.
Yeah.
She said yes.
Said yes. Where you going?
Yep.
On her way.
No, not this time.
I feel that no that she wanted to say to me.
No, Joyce would love for me to come with her and Mary. I would love it.
All right. Everybody have it?
Oh, I know Mary would. Mary is my best. Mary's Joyce's mom. Her name's Mary Lou.
I'm sure she wants to take you.
She-
I'm just not sure where.
All right,
All right, does everybody have it? All right. Now, I think, I can't swear to this, but I think the last thing I need to talk about is why metals conduct. Now, why do metals conduct?
Because their electrons move.
That's right.
Yeah.
Oh, yeah.
Right.
First of all, y'all.
You be saying it without trying, like, wow.
That's because they don't do no homework. So how am
I don't get it. Like,
Now,
you don't attend yourself, but you're a genius.
Annabelle, shut up. Now, this will be important tomorrow when we talk about ionic and covalent bonds. All right, because we're going to have the same conversation. All right, when we talk about ionic and covalent bonds, and I ask why ionic and covalent bonds don't conduct, you need to think about the electrons. Do the electrons move in those bonds? Or if I ask, can we make them conduct? Can we make the electrons move? In some cases, the answer is going to be yes, and in some cases, the answer is going to be no. Now, I need to stop and talk about the homework, because if I don't, half of you are going to come back and go, I know what to do with this one. All right? Because there's multiple parts, and I need to talk about how to do it. So, here, Annabelle, come make use of your mouth. Exercise your feet.
I gotta get my steps in.
Okay. Apple Watch.
Why do you not have one?
Huh?
Why don't
I didn't want one.
Oh,
Now, do not put it up because we need to talk about how to try to get you okay on the homework.
this is a lot.
You all know what you're doing.
What's HE double hypotenuse?
Put it on your wrist.
I'm trying to be.
So you can have your hands free to keep up the peace.
I honestly need like a.
I already asked that question.
I lose so much.
you get it at? And then
I went there. I don't feel like spending money on it. That was
Where?
I heard. I just don't feel like spending money on it in the military. Because I've been playing games. Because it's not making it.
If you break, you're not 25.